For the equal means model, y bar is just the mean of all the values of y without taking into account which judge you have. So this is just going to be some value that's the same all the way across. This y bar. Whereas the estimates of the separate means will be different for each group. So this is y bar 1, and this is y bar 2, etc. The way we're going to assess which model is appropriate. The way we're going to assess which model is appropriate is by looking at the difference between each data point and the mean for that model. So if I want to assess whether the equal means model is appropriate, I'm going to take each data point and subtract my estimate of the overall mean from that data point. So I'm going to take y11 minus y bar, the overall mean of all the values. I'm going to take y12 minus y bar, the mean of all the values, etc., all the way up to y7, and then this n7 is the sample size in the 7th group, all the way up to the last value in the 7th group, minus the overall sample mean. In order to figure out whether it makes sense to use an equal means model, I'm going to take each data point and subtract from it this one number and see how far these points are from this one number, this line. If the points are not that far from the line, then we could roughly say the equal means model is appropriate. These are residuals. Okay. What about the separate means model? How are we going to similarly assess whether that's appropriate? Well, we can take each data point and subtract from it the mean in its own group, right? Because with the separate means model, if I want to see how far a data point is from the mean predicted by the model, it's going to be the mean only in that one group. So y11 minus y1 bar, y12 minus y1 bar, etc., y7 and 7 minus y7 bar.